NENOMATICA, where mathematics meets YouTube excellence. Welcome! In this short lesson, we will learn how to rationalize the denominator. That means we rewrite a fraction, so the denominator has no radicals. I will show you an easy one-term example, then a binomial example using the conjugate. First, a quick warm-up with a single radical in the denominator. We multiply by the same radical over itself, which equals 1, so the value does not change. Now for the classic case, a binomial denominator. We will rationalize the fraction 3 over 2 plus square root of 5. To remove a radical from a binomial denominator, multiply by the conjugate. For a plus b, the conjugate is a minus b. Here, the conjugate of 2 plus square root of 5 is 2 minus square root of 5. Multiply the fraction by the conjugate over itself. Then expand. The numerator becomes 3 times the binomial in parentheses. The denominator becomes a difference of squares. Now simplify the denominator and distribute the 3 in the numerator. We will state the general goal. Rationalize denominators of expressions like k over the nth root of a to the m, where m is less than n. Here is the core template we will use. The expression involves the nth root of a to the m, where m is smaller than n. This choice completes the missing power under the root. Using the product rule for equal index radicals, the denominator becomes a to the first power. Quick challenge time. Predict the factor you would multiply by if the denominator were the cube root of x squared. Now, 2 worked examples. Example 1. Rationalize 1 over square root of 2. Step A. Multiply top and bottom by square root of 2. Step B. Simplify the denominator to 2. Example 2. 1 over square root of a. Multiply by root a over root a, then simplify. The general rationalized form is highlighted in green. Let us finish with a focused summary. The rule summary. The rule, 2 examples, and a suggestion for practice. Great work! Keep practicing rationalizing radicals to build fluency. In this lesson, we will rationalize denominators. We will first state the general algorithm, then follow its steps exactly on 2 examples, 10 over square root of 5, and the square root of 5 over 6. The algorithm. If we have k over the nth root of a to the m, multiply by the nth root of a to the n minus m over itself. This creates a perfect power in the denominator. Example 1. Rationalize 10 divided by square root of 5. Step 1. Multiply numerator and denominator by square root of 5. Step 2. Simplify the denominator. Square root of 5 times square root of 5 equals 5. Step 3. Reduce the fraction. The reason this works is that multiplying by square root of 5 over square root of 5 is multiplying by 1, but it turns the denominator into 5, which is rational. Example 2. Rationalize the square root of 5 over 6. Step 1. Split the radical. Square root of 5 divided by square root of 6. Step 2. Multiply by square root of 6 over square root of 6. Step 3. Multiply inside the radicals. Step 4. Simplify the denominator by taking the square root of 36 as 6. Summary. To rationalize a denominator containing a root, multiply by a form of 1 that completes the power under the radical. For square roots, multiply by the same square root. Then simplify. Example 1. Start with the fraction 1 over square root of 2a. To remove the radical from the denominator, multiply by square root of 2 over square root of 2a, which is just 1. That makes the denominator equal to the square root of 2a squared, which is 2a. Therefore, the simplified result is square root of 2 over 2a. Assume it is positive, so the square root stays real. Note, for real numbers, we usually take a greater than 0, so the denominator 2 is not 0, and the square root is defined. Example 2. Start with 2 times square root of x over 3 times square root of y. To rationalize, multiply numerator and denominator by square root of y. The numerator becomes 2 times square root of x times square root of y, which we can combine into 2 times square root of xy. The denominator becomes 3 times square root of y squared, which equals 3y. So the simplified form is 2 square root of x, y over 3y. Assume x is greater than or equal to 0 and y is positive. In this lesson, we will rationalize denominators that contain cube roots. We will follow a clear, step-by-step algorithm and apply it to 2 examples. We will rationalize these denominators. First, 1 over the cube root of a. Second, 9 over the cube root of open parenthesis 2x close parenthesis. Key idea: to clear a cube root in the denominator, multiply by a form of 1 that makes the radicand a perfect cube. For the cube root of a, multiply by the cube root of a squared. For the cube root of 2x, multiply by the cube root of open parenthesis 2x close parenthesis squared. Example 1. We start with the expression: multiply by a clever form of 1, the cube root of a squared over the cube root of a squared. Combine the denominator. Cube root of a times a squared equals cube root of a cubed. Replace the cube root of a cubed with a. The result is the cube root of a squared over a. Example 2. Start with 9 over the cube root of 2x. Multiply by the cube root of open parenthesis 2x close parenthesis squared over itself. Combine the denominator to make a perfect cube. Cube root of open parenthesis 2x close parenthesis cubed. The cube root of open parenthesis 2x close parenthesis cubed simplifies to 2x. Optionally, rewrite the numerator cube root as the cube root of 4x squared. Final simplified result. Summary: in this lesson, we will rationalize denominators that involve cube roots. We will follow a precise, step-by-step algorithm and mirror every algebra line exactly. 2 examples from the prompt will be solved. Example A. Rationalize the denominator in the cube root fraction. We begin with the expression shown. First, split the cube root of a quotient into a quotient of cube roots. Then factor the denominator so you can see powers clearly, writing 3 to the first and c to the first. Multiply by 1 in a helpful form, a cube root of 3 squared times c squared over itself, so that the denominator becomes a perfect cube. Combine the numerators inside 1 cube root and the denominators inside 1 cube root. Recognize the denominator as the cube root of parentheses 3 bc quantity cubed. Evaluate that cube root to remove the radical from the denominator and present the simplified result. Intuition: because we are working with cube roots, the denominator becomes rational when each factor inside has an exponent that is a multiple of 3, multiplying by 3 squared, and c squared provided the exact missing powers. Example B. Rationalize 1 divided by the cube root of x squared. Show the starting expression. Multiply numerator and denominator by the cube root of x over the cube root of x. Merge the radicals in the denominator to create a single cube root of x cubed. Evaluate the cube root of x cubed as x. Example: we start with 4 divided by the cube root of 16. First, factor 16 as 2 to the 4th, which we will write as the product of 2 cubed times 2. Next, split the cube root of a product into the product of cube roots. Evaluate the cube root of 2 cubed, which is 2. Reduce 4 over 2 to get 2 over the cube root of 2. To rationalize a cube root denominator, multiply top and bottom by the cube root of 2 squared. Combine factors. The denominator becomes the cube root of 2 cubed. Evaluate that cube root as 2. Finally, simplify to the cube root of 4. Now, the second example: 1 divided by the cube root of 4. Multiply numerator and denominator by the cube root of 4 squared. That creates the cube root of 4 cubed in the denominator. Evaluate that as 4. Rewrite 16 as 8 times 2. Express 8 as 2 cubed. Split the cube root into a product of cube roots. Evaluate the cube root of 2 cubed as 2. Reduce the fraction to the cube root of 2 over 2. Example A. We start with the expression 1 over the cube root of 4x. First, factor the inside as 2 squared times x to the 1. To rationalize, multiply top and bottom by the cube root of 2 to the 1 times x squared, so that exponents in the denominator become multiples of 3. Combine exponents in the denominator to make 2 cubed times x cubed. Recognize this as the cube root of 2x quantity cubed. Finally, evaluate the cube root of a perfect cube to get the simplified result. Example B. Now, the cube root of the fraction 3 over 4a. Rewrite it as the cube root of 3 divided by the cube root of 4a. Factor 4I as 2 squared times a to the 1. Multiply top and bottom by the cube root of 2 to the 1 times a squared. Combine to make 2 cubed times a cubed in the denominator. See that as the cube root of 2, a quantity cubed. Evaluate the perfect cube to finish. Example A. Rationalize cube root of 2 over 3. First, split the single cube root into a fraction of cube roots. Because the index is 3 and the denominator has one factor of 3 under the root, we multiply by cube root of 3 squared over cube root of 3 squared. Multiply numerators and denominators. The denominator becomes cube root of 3 to the third, which equals 3. Our final simplified answer is cube root of 18 over 3. Quick intuition. Because we take cube roots, we want groups of 3 equal factors in the denominator. One factor of 3 needs 2 more 3's to make a perfect cube. That's why we used 3 squared. Example B. Rationalize 2 divided by the 5th root of 16. Write 16 as 2 to the 4th to see the exponent clearly. Because the index is 5, and we currently have 4 factors of 2, multiply by 5th root of 2 over 5th root of 2 to complete a group of 5. Multiply and simplify. The denominator becomes 5th root of 2 to the 5th, which equals 2. The factor of 2 cancels, leaving only the 5th root of 2. That's our final simplified answer. General pattern. For a denominator like the nth root of b to the r, multiply numerator and denominator by the nth root of b to the power n minus r. That makes the denominator the nth root of b to the n, which equals b. Use this to quickly decide what to multiply by for any index. Final answers. Example, a equals cube root of 18 over 3. Example B equals the 5th root of 2. Great work! In this lesson, we will rationalize denominators by creating perfect roots in the denominator, following the exact step order shown. Example A. Start with 3 divided by the 9th root of 128. Express 128 as 2 to the 7th. Multiply numerator and denominator by the 9th root of 2 squared to complete a 9th power in the denominator. Combine the radicals in the denominator to get the 9th root of 2 to the 9th. Evaluate the 9th root of 2 to the 9th, which equals 2. Write the final simplified form. Example B. Start with 5 divided by the 7th root of 9. Express 9 as 3 squared. Multiply numerator and denominator by the 7th root of 3 to the 5th to complete a 7th power in the denominator. Combine the denominator to get the 7th root of 3 to the 7th. Evaluate the 7th root of 3 to the 7th, which equals 3. Write the final simplified form. Both denominators have been rationalized by completing perfect powers under the radical. Final results are 3/2 times the 9th root of 4 and 5/3 times the 7th root of 243. Then we show 2 expressions to simplify. Our goal is to rationalize denominators and present clean final forms. Part A. We rationalize the denominator of 2 over 5 times the cube root of -4. Step 1. Rewrite the negative inside the cube root. The cube root of -4 equals negative the cube root of 4. That turns our fraction into -2 over 5 times the cube root of 4. Step 2. Express 4 as 2 squared. Step 3. Multiply numerator and denominator by the factor that completes a perfect cube in the radical. Since we have 2 squared, multiply by the cube root of 2. Step 4. Simplify the cube in the denominator and reduce. Final result for part A is negative cube root of 2 over 5. Part B. Now simplify the sum of square root x over square root y plus square root y over square root x. We will assume x and y are positive to keep real square roots. Step 1. Use a common denominator of square root x times square root y. Step 2. Simplify the numerator using root times root equals the radicand. Step 3. Rationalize the denominator by multiplying by square root of x, y over itself. Step 4. Simplify to the final form. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.